So Unit 2, the first topic is about the chemical energetics or energy from the chemical. So you already have the prior knowledge of this topic, that in terms of energy change, a chemical reaction can be classified as endo and exothermic. But what is difference here compared to IGCSE? In A levels, you will also learn how to calculate, practically how to calculate the energy change during a chemical reaction. So first, the definition of enthalpy change, or what is the meaning of enthalpy change? Enthalpy change is basically the energy which is transferred between the system and the surrounding. The system refers to the chemicals and the surrounding. Other than the chemical, anything other than the chemical is refers to surrounding. By example, if we have nitrogen reacting with hydrogen to give ammonia. So what is the system here? System is refers to the chemicals. So nitrogen, hydrogen and ammonia, they all refers to system. And what is surrounding? All the things other than the system is refers to surrounding. So when a chemical reaction occurs, there is a change in energy or there is a transfer of energy between system and surrounding, and this transfer of energy either from system to surrounding, because both possibilities are there. The energy might travel from system to surrounding, or it might enter from surrounding to the system. So this change in the energy between the system and the surrounding, what we call that as enthalpy change or energy change. You can use the term enthalpy change, or there is also another term which we call that as energy change. So as we know, the reaction can be endothermic, so the reaction can be endothermic, reaction can be exothermic. So if we have a system like this shade, gray shade is representing a system, and anything other than the system is a surrounding. So what happened in endothermic reactions? The energy transfer from surrounding to the system. So system energy increases and the surrounding energy decreases. But what happened in exothermic reaction? If a reaction is exothermic, we have system and anything other than the system is refers to surrounding. So when the energy change occur, the energy change, it energy transfer from system to surrounding in exothermic reaction. And this transfer of energy between the system and the surrounding, what we call that? We call that as enthalpy change, and it is denoted by delta H. So delta H is actually used to show the energy change between the system and surrounding. Is it clear, the concept of enthalpy change and how it is related to the two types of reactions, endothermic and exothermic reactions? Then the energy diagram, the diagram which we use to represent the energy change, so that is called energy profile diagram. So there is an energy profile diagram for endothermic, and there is energy profile diagram for exothermic. So what happened in endothermic reactions in terms of energy, and what happened in exothermic reactions in terms of energy? So when we compare the energy of the reactant and product, so in endothermic reactions, reactants have low energy, the product is having high energy. But in exothermic reaction, the reactants have high energy and the product is having low energy. So we have reactant, product, but in exothermic, the reactants have high energy and the product is having low energy. Now, how the reaction proceed? What are the labels for this energy profile diagram? On y-axis, we have energy. On x-axis, it's about the reaction progress, or you can refer to it as the time. Same thing, energy on y-axis, and the reaction progress is there on x-axis. So first, what happened when a chemical reaction occurs? Some of the energy is absorbed and some of the energy is released. So we always talk about the overall. So first, what happened? The reactant have to absorb energy. They must absorb some energy, and why they should absorb the energy? So to start the reaction. So example, this is a position where the reaction starts, and the moment the reaction starts, the energy will be released to the surrounding, but you can clearly see that the energy which is taken in is more than the energy which is given out. So if the overall energy, when we calculate the overall energy, greater amount of energy is taken in and small amount of energy is released. So when we talk about this reaction, overall this reaction, so what we call this, we call that as endothermic reactions, because overall for any kind of chemical reaction, some of the energy is absorbed and some of the energy is released. But what we check which one having a greater proportion. If greater amount of energy is absorbed during a chemical reaction or taken in, and small amount is released or given out, so we call that as overall endothermic reaction. But what happened in exothermic reactions? Reactant absorb some energy to start the reaction. So this is a position where the reaction starts. And once the reaction starts, they will form a product. So you can see the energy which is taken in, very small proportion of the energy is taken in and greater proportion of the energy is given out. So if energy taken in is small, energy given out is more. So what we call that? We call that as exothermic reaction. And the labels, you have to learn the label as well as the direction of the arrow from reactant to the start of the reaction. The energy from reaction to the start of reaction, we call that as activation energy, and you can denote by EA, which is activation energy. And energy from the reactant to the product, that is called enthalpy change, difference in the energy, or enthalpy change. And for endothermic reactions, the activation energy will be positive, enthalpy change will also be positive. But what about endothermic for exothermic reactions? Reactant to the start of the reaction, we call that as activation energy, denoted by EA, and reactant to the product. So energy from reactant to the product, that is known as energy change, or delta H. So here EA will be positive. But what about delta H, the difference in energy of the product and reactant? Because it's all delta H is by energy of product minus reactant, so delta H will be negative. So exothermic reactions, enthalpy change is negative. Endothermic reactions, enthalpy change is positive. Activation energy is always positive because it is the energy which is taken in. So it's always higher than the energy of reactant. So it will always be a positive energy. Is it clear? The energy diagram, energy profile diagram for endothermic and exothermic reactions. We have already discussed in IGCSE this energy diagram. So it's the same thing, no difference. Any doubt till this point? So for exothermic reaction, enthalpy change will be negative and activation energy will be positive. Whereas endothermic reaction, the activation energy as well as the reaction progress both will be, the activation energy as well as enthalpy change both will be positive. Then how you can identify, there are some common reactions you can simply identify as exo and endo. So endothermic reactions example like dissolving, thermal decomposition, photosynthesis, and electrolysis. Because in electrolysis, we supply electrical energy. Like some examples of exothermic reaction like combustion or burning, respiration, and chemical cells. So all these like some examples of exothermic reaction. So if a reaction overall it is an endothermic, it will be have energy change positive, and if it is an exothermic reaction, so energy change will be negative. Then there are certain definitions which you have to learn, like such as enthalpy change of formation, combustion, or reaction. So if we say standard enthalpy change of formation, what is the concept of standard enthalpy change of formation? First, this term, what is the meaning of term standard? Because why not only enthalpy change, why standard? Because what happened when we use the term standard, it means that there are certain parameters which are fixed here. That's why we call that as a standard. Like we say, the pressure is 1 atm or 100,000 Pascal, temperature is 298 Kelvin or 25 degrees centigrade. The solution should have a concentration of 1 mole, and all the substances should be there at normal state at 298 Kelvin. So the concept of standard means the pressure should be 1 atm, like this enthalpy change is done or calculated at a pressure of 1 atm or 100,000 Pascal, 298 Kelvin the temperature, or we can also say 25 degrees centigrade. The concentration of the solution should be 1 mole per dm cube. What substance we have, that should have a concentration 1 mole per dm cube, and all the elements must be in the standard state. So when all these parameters match, they fulfill, like there the pressure is 1 atm, the temperature is 298 Kelvin, the concentration is 1 mole per dm cube, and elements are in the standard state. So we use the term standard enthalpy change. But what if, for example, if the temperature is not 298 Kelvin or 25 degrees centigrade, or the pressure is not 100,000 Pascal or 1 atm, so we will not say standard enthalpy change. In that case, we will only use the term enthalpy change. So when these conditions are there and we carry out or measure certain energy changes or enthalpy change, we call that as a standard enthalpy change. But if any of the condition is not fulfilled, then we don't use the term standard, we just say enthalpy change. Then what is the meaning or concept of formation? So standard, these are the conditions, standard condition. What is the concept of formation? The term formation refers to when element will give the compound. So when element will form 1 mole of a compound, what we call that as a standard enthalpy change of formation. Example, we have hydrogen reacted with oxygen to give H2O, 1 mole of H2O, and the equation must be balanced. We need 2 hydrogen, but we don't need 2 oxygen, we need only 1 oxygen, so here it should be half oxygen. So when elements in their standard state result in a formation of compound, and that is condition that 1 mole of a compound. So what we call this energy when element form a compound, 1 mole of a compound, we call that as enthalpy standard, and if it is done at a standard condition, so we call that as the energy change as standard enthalpy change of formation. And how we represent, symbolic representation, so enthalpy change is denoted by ΔH. So ΔH is for enthalpy change. But how we know it is standard? So if it is done at a standard condition, we use this symbol to represent standard. So if it is done at standard condition, we'll use a symbol that it shows that the condition are standard. And because it is a formation, so we use subscript F. When subscript F is used or small f is used, it means it is formation. And this is formation of what? Which substance is formed here? So the substance which is formed is water, so we'll write H2O in a square bracket. So the energy change here is a standard enthalpy change of formation of water molecule. Is it clear, the concept of standard enthalpy change of formation? So standard refers to the condition. Yes.
Can you explain formation again?
Yeah, what is the concept of formation? The term formation means when element give you a compound. When element give a compound, we call that as formation. So here we have hydrogen element, we have oxygen element, and when they combine with each other, they result in a formation of compound. And if it is forming 1 mole of a compound, so what we call that as standard enthalpy change of formation of that specific compound, such as in this example is water. Like another example, if I say the condition, the pressure was 1 atm or 100,000 Pascal, the temperature is 298 Kelvin or 25 degrees centigrade, and what we did, we mixed carbon with hydrogen, carbon in a solid state at room temperature and hydrogen as a gas. So when we mix them together, what it result? It result in a formation of 1 mole of CH4, or we also call that as methane. So you can see what is carbon. Carbon is an element. What is hydrogen? That is also an element. It forms methane. What is methane? It is a compound. So when elements form a compound, what we call that, because if it's 1 mole of a compound is formed, the energy change, how we represent that energy change? Energy change is denoted by ΔH, which is also called enthalpy change. And because it is The conditions are standard. These are the standard conditions. So we'll write the symbol for standard. Then because the elements are forming a compound, so we write subscript F formation. And which compound is formed? So which compound is formed? Methane is formed. So we write as this equation is a standard enthalpy change of formation of methane. Is it clear, the concept of formation? When elements will form a compound, 1 mole of a compound, we call that as standard enthalpy change of formation. Any
So
doubt?
sir,
Yeah.
if it forms 1 mole, it's standard, but if it forms 2 moles, it's
No, no.
out of the.
If standard means that, yeah, according to definition, standard refers to condition. But what if 2 moles are there? Like example, I was coming to that point only. Example, you was having carbon reacted with hydrogen to give 2 moles of methane. So 4 multiplied by 2, 8, and we need 2 carbon. This is solid, hydrogen is a gas, and methane is also a gas. So how many moles are formed? 2 moles, but conditions are standard. Standard, so what we write standard enthalpy change of formation of methane, but then because it is refers to 1 mole, but here 2 moles are formed, so it will be multiplied by 2. So this enthalpy change or energy change is standard enthalpy change of formation of methane times 2 or multiplied by 2 because 2 moles of methane are formed.
Okay,
And
thank you, sir.
according to definition, practically, like according to standard definition, when 1 mole of a compound is formed, but what will happen if 2 moles are formed, then it will be twice the formation of methane. And this sign is used, the symbol is used to represent the standard condition. It's not about 1 or 2 moles, it is about the standard condition. If conditions are not standard, we don't use this. If conditions are standard, we will use this sign. Another example, if we have say hydrogen reacted with chlorine to form hydrogen chloride, this is half and give HCl. And the condition, the pressure was say 100,000 Pascal and the temperature is 298 Kelvin. So what we call the energy change, enthalpy change, so we call that as standard. Why standard? Because the conditions are standard. Then because elements form a compound, so if elements form a compound, what we call that as formation, and this is formation of what? Formation of HCl. So the energy change which occur, it might be endothermic or exothermic, but the energy change which occur in this reaction when the hydrogen react with chlorine to form hydrogen chloride, we call that energy as standard enthalpy change of formation of HCl. Is it clear, the concept of standard enthalpy change?
Yes, sir.
Same way, so there are many definitions related to enthalpy change or energy change. The first one is we discussed about the formation. The next one, so this is the standard enthalpy change of formation. Then it can be a standard enthalpy change of atomization. So what is the concept of standard enthalpy change of atomization? The term atomization means when we produce atoms from the element. So when element is there in the standard condition and we produce atoms or atom, what we call that as atomization. So formation is when element form a compound. Atomization means when element form an atom. Example, and it should be a 1 mole. When 1 mole of atom is produced from the element and under the standard condition. So enthalpy, the standard is refers to like 298 Kelvin is there, 1 atm or 100,000 Pascal is there, concentration is 1 mole per decimeter cube, and we have all the material in the standard conditions. So example, you have hydrogen molecule. So when we produce 1 mole of atom in a gaseous state, so we have hydrogen molecule, or start with a simple example, say we have sodium. So sodium exists as a solid. So we have sodium atom in a solid state. We supply energy so that we can produce sodium atom in a gaseous state, because the concept of atomization is energy required to produce the atoms in a gaseous state. We call that as atomization. So sodium solid, we produce sodium atom, what we call this, and 1 mole of sodium atom, so we call enthalpy change is denoted by ΔH. If condition are standard, then we'll use this symbol. Because it is atomization, so for atomization what we use letter A. For formation we use letter F. For atomization we use letter A. And this is atomization of what? It is atomization of sodium, so we write Na. So when we produce sodium atom under standard condition, what we call that as atomization of standard enthalpy change of atomization of sodium. And whenever atomization is done, whenever you produce atoms, you have to supply energy. So atomization is always endo. It can never be exo, it is always endo. Here formation can be exo, that's why I did not write it specifically. It can be endo, it can be exo, but atomization is always endo. In atomization we have to supply energy to produce atoms or to break the bonds. Same way, if we have hydrogen molecule, hydrogen is a gas. So when we have half hydrogen, practically you don't have half, but according to theory, if you have half hydrogen molecule, it will produce 1 hydrogen atom in a gaseous state. So when element produce an atom in a gaseous state, what we call this enthalpy change as standard enthalpy change of atomization of hydrogen. Is it clear? The second example. Anyone having a doubt? You can use a chat or you can use your mic if you have any question or a doubt.
Sir, what happened at the second example?
What happened in the second example?
Yeah.
You have hydrogen
Hydrogen.
molecule. The term atomization means we produce atoms. So you have hydrogen molecule, you supply energy, and what you produce? When you supply energy, you produce hydrogen atoms. So if we have one molecule of hydrogen or 1 mole of hydrogen molecule, it will produce 2 hydrogen atoms. But if we have half hydrogen molecule, because if one is producing 2, so if half hydrogen molecule is there, How many hydrogen atoms this will produce? This will produce only one hydrogen atom. So when element produce an atom, what we call that as standard enthalpy change of atomization of hydrogen. Like we produce one hydrogen atom. What if we have the hydrogen molecule like here? So if you have hydrogen molecule, so means hydrogen single bonded with another hydrogen, we supply energy to produce hydrogen atoms. So how many hydrogen atom one molecule will produce? Two hydrogen atoms. So when we supply energy, it will produce two hydrogen atoms. So now two hydrogen atoms are produced. So what we call, if two hydrogen atoms are produced, first element is forming an atom. So when elements are forming atoms, we call that as atomization. But here two atoms are produced. If the conditions are standard, we say standard enthalpy change, because it's atomization, so we use subscript A, an atomization of hydrogen. But how many atoms of hydrogen are produced? Two. So this should be multiplied by 2. If you under standard condition, if you produce two hydrogen atoms, then it will be multiplied by 2. The enthalpy change. Is it clear? This example? The standard enthalpy change of atomization. Anyone having a doubt? So same way, when we write, like we have oxygen, O2. Under standard condition, one molecule of oxygen produces two oxygen atoms. So if you have element and produce atoms, so what we call that enthalpy change, or because all the energy change having a specific names, so what we call that as atomization. If conditions are standard, we use this symbol. And this is atomization of what? This is atomization of oxygen. But because we produce two oxygen atoms, so it will be multiplied by 2. So this is actually the standard enthalpy change of atomization of oxygen times 2. But if we have nitrogen, or say ozone, instead of oxygen, O2, we have ozone, and we supply energy and produce 3 oxygen atoms in the gaseous state. Under the standard condition, if it is done, so this is standard enthalpy change of atomization of oxygen, and because 3 oxygen atoms are produced, so this will be multiplied by 3. If one atom is produced, it's not multiplied, simply atomized. Enthalpy changes standard or atomization. But if it is 2 moles are there, then it will be the enthalpy change is atomization times 2, and if 3 moles are there, atomization times 3. So if elements give the compound, what we call that as standard enthalpy change. If it's under standard condition, so we call that as formation. But if element, not elements, if element gives atoms in the gaseous state, so what we call the energy change or enthalpy change, we call that as standard enthalpy change of atomization. If the conditions are standard. If conditions are not standard, then we don't use that. So as you can see, what are the standard conditions? I'll share another link and continue the discussion about combustion. But first, as you can see here at the bottom, what are the standard condition? 100,000 Pascal or 1 atm, the temperature 298 Kelvin or 25, the solution should be 1 mole, and all the substances should be under the standard condition. So if not standard condition, we don't use this. So I'll share another link and continue this discussion.